Okay, this is where we pick up from yesterday. So whenever we are looking at this now, this is a chart of all of our values with radian measures. So pi over 6, the sine of t is 1/2. Pi over 4, it's root 2 over 2. Pi over 3, it's root 3 over 2. Cosine, I'm not going to read the whole chart to you. You can copy the chart down. The other thing you can do is look at the unit circle. I'm putting the unit circle officially in your extra materials in your class today. So when I look at the unit circle, all that magically appeared. I'll pause the video and drag it over. A little bit of TV magic for you. That was stupid. Anyhow, the sine of pi over 6. When I look at the unit circle, remember we learned yesterday that the cosine is the x's and the sine is the y's. So if I look at the unit circle, it gives me the same values that this chart had. So if I go to pi over 6 on the unit circle, that's here. The sine is the y value. So the sine of pi over 6 is 1/2. The cosine of pi over 6 is root 3 over 2. If I go down to cosine, and look, it's root 3 over 2. So we get this entire table of information based off of the unit circle here. Where my cosine is the x's, and my sine is the y's. And if I'm staring at the unit circle, this makes this real easy. If I need to find the sine of 2 pi over 3, that's root 3 over 2. If I need to find the cosine of pi, that's -1. Just going over to pi, and it's your x value. So it's very easy to find my sine and cosine. Whenever I need to find my tangent, remember that yesterday we also defined the tangent of theta is sine over cosine. So if I needed to find my tangent of 2 pi over 3, I'll take root 3 over 2 over the cosine, which is -1/2. But I don't know how to divide fractions. It's real easy. We take the denominator, flip it, and multiply. Root 3 over 2 times -2 over 1. 2's cancel. I have -1 times the square root of 3. That's -square root of 3. And I'm done. That's your answer for the tangent. So whenever I'm looking at this unit circle, I can find all the information I need for cosine, sine, and tangent. What if I needed to find the secant, cosecant, or cotangent? I would just flip each one of these. If I need to find the secant of pi over 3, I take 1/2 and flip it. It makes it 2 over 1. So our secant, cotangent, and cosecant are all related to sine, cosine, and tangent. And all of our cosines and sines are in the chart. Now these are just common angle measurements. The majority of our questions are going to ask about these types of angles. So it's not going to be a big deal. There will be some that come up in between. You should memorize the unit circle. And I've had a lot of people ask questions about trying to memorize something like this. It's a lot of information. But just because it's a lot of information doesn't mean you need to memorize all that information. Essentially, it all comes back to reference angles. What a nice transition I just made. For an angle theta in standard position, the reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. What that means is that if I have this angle T here, then I can really just use a reference angle for T prime, which means I would just take pi, because remember from here to here is pi, minus T, and that'll give me T prime, or T with the apostrophe on it. So this angle is just the distance between this terminal side and pi, or the x. So I'm always looking, when I'm doing reference angles, I'm always looking for it to relate back to the x-axis. What if I go beyond the x-axis? Like what if I went the whole way around here? Then in order to find this reference angle, all I would have to do is 2 pi minus t, because this went almost the whole way around to 2 pi, and just subtract t from it. That'll give me this angle here, which is my acute angle. If I had only gone this far, so if I'm in quadrant 3, 1, 2, 3, if anyone that's in this quadrant, in order to find what this angle is, or my reference angle, all I have to do is t minus pi, with pi being here on the x-axis. That will give me t prime. So just to review those again, if it's in the first quadrant, we don't need any reference angles, because it's whatever this angle is. If it's in the second quadrant, we do pi minus t, or the angle. If it's in the third quadrant, down here, we do t minus pi to find the reference angle. And if it's in the fourth quadrant, we do 2 pi minus t. And that will work every time. If we're able to find reference angles easily, it will make it so that we don't have to memorize the whole table. So if I memorize, going back to my unit circle, if I memorize this first quadrant, these angles and their values for cosine and sine, then every reference angle I find, like let's say it's here at 5 pi over 6. So I do pi minus 5 pi over 6. Let me erase this stuff for a second. If I do pi minus 5 pi over 6 to find my reference angle, in order to do that, I have to get a common denominator. So this makes it 6 pi over 6. That gives me just pi over 6. That's my reference angle, which is over here in the first quadrant. Which means that my values, if I was finding the cosine of 5 pi over 6, I would know that it's root 3 over 2, but because it was on the left side, it would be negative. Now, how would I know whether it's negative or positive? We have a handy-dandy chart for that. If your original angle started in the first quadrant, over here, quadrant 1, 2, 3, and 4. Those are Roman numerals. If your thing started in the first quadrant, they're all positive, sine, cosine, and tangent. If it's in the second quadrant, the sine is positive, the cosine and tangent are negative. Third quadrant, sine is negative, cosine is negative, Remember that the tangent is sine over cosine. A negative over a negative is a positive. And then in the fourth quadrant, the sine is negative, cosine is positive, so the tangent is negative. So if I'm doing 5 pi over 6, and I was trying to find the cosine, 5 pi over 6 is over here. That makes it a negative. And then it was pi over 6 for the reference angle, which was root 3 over 2. So it's negative root 3 over 2. So using reference angles, I really only have to memorize this first quadrant. Pi over 6, the cosine is root 3 over 2, and the sine is 1/2. Pi over 3, oh, I'll put you a better unit circle because we need a pi over 4 in here too that they left out. But that one's fairly easy. It's root 2 over 2 and root 2 over 2. But I'll get a better unit circle that includes pi over 4. If you memorize first quadrant with reference angles, that's the whole point. All right, use reference angles to find the exact value of sine, cosine. So the first thing I need to do is, where is 3 pi over 4? Well, if I think about it, pi, if I'm looking at it in fourths, pi is 4 pi over 4. 3 is not as big as 4, so 3 pi is going to be over here. Pi over 2 is here, which would be 2 pi over 4. 3 is between 2 and 4. I know you struggle with that. 3 is between 2 and 4, so it would be in this quadrant, which means I'm doing pi minus 3 pi over 4, or 4 pi over 4 minus 3 pi over 4, which gives me just pi over 4. So that's my reference angle. Now I have to take the sine, cosine, and tangent of each, or of that reference angle. Sine of pi over 4, of course it's the one that wasn't on here. Sine of pi over 4 is root 2 over 2. Because it's in the second quadrant, that stays positive. So root 2 over 2. Cosine of pi over 4 is root 2 over 2. Remember, though, that we were looking at 3 pi over 4, so technically we should write 3 pi over 4 because that's what we're finding, even though we're using the reference angle of pi over 4. So that makes it negative because the cosine is negative in the second quadrant. Lastly is the tangent. My writing is a little off today, like every day. And the tangent would be -1 because it's the sine over the cosine. Those are all going to cross out, and I just get -1 from this negative. That's your answer. Do not make these decimals. Do not put them in the calculator. That's not what I'm looking for. So if you give me that answer, you're going to get a 0. I promise that. Okay, I'm going to give you some homework problems tonight. They're going to be some of the easier variety. I'm going to post a better unit circle, one that includes pi over 4. And if you have any questions, show up to the Google Meet either today or tomorrow. All right, peace out.